discussions in the previous stream if we were going to use. We've been thinking about high-level stuff, so I'm going to try to take it up. If we can show the sketchpad, we've been in a rabbit hole today talking about using paper as programming memory for the Marble Machine 3. And there's been a very big discussion, or plastic, or Tyvek, someone said. This changes the identity of the machine completely. And we also been talking about how, if we go back to CAD, how to insert the programming wheel. Let's see. How to make the programming wheel removable. Where are my... Once again, I have so many designs. And yeah, so it's been very high level stuff. Here is one removable solution. But where did the other go? And I have just figured out a new solution for how to put these drums on and off using the hero of the thumbnail.
Yes!
Twist to lock pin that is saving our Friday night. And I want to CAD, it's going to be pretty easy. I think to CAD show you how this will help us have only the circular tube. And I figured out that I can use this angle thing. It's called an aggregate head to angle the direction of the drill bit on my CNC machine. So it almost becomes like a 5-axis operation. So if you think of this rotary thing, we can only drill from the top here. But with this angle thing, you can actually go into the side of stuff, and that makes all the difference. So we could cut these holes. Here's what's my first idea, spring-loaded ball detent thing. So we could...
you need to switch. There we go. Friday night, everybody.
Yes. We could machine very accurately these kinds of holes here. So if you think of which would make it very, very handy and very sideways, very space efficient to use this aggregate head to drill the holes in the sides for this twist to lock pin. And I actually have the twist to lock pin right here. And what the cool thing is then that you pull this thing out, you twist the head 90 degrees, and the pin stays in its retracted position.
Ooh.
So, like one person could click, 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 8 pins on one side, click, 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 8 pins on the other side, and the programming wheel is ready. Put the drum in, and I figured out a cool way to make that easy. So I'm gonna CAD that now, and I think the drums are still saved. We're not gonna go to paper. And we're also having this hammer jammer base solution here from the previous stream. And Hannes 3000, during we were just having some food, Hannes said like, you can also improvise on that hammer jammer. Like,
yeah. When you start thinking about it with the original marble machine, like for me at least, the first 2 minutes of that video is mind-blowing at first. Like, oh, this guy built this and it's make this beautiful music, and then all of a sudden the breakdown comes, and then with the whole do 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 do, and then you start with the bass. Like, I mean, that's the magic. You get your mind blown twice in that video. First with the machine, and then your interaction with the bass. So I like that's a crucial part of the marble machine in my head, is you being able to play bass, and to with this hammer jammer that you can freestyle completely. You don't even have the marbles, you don't have the need for them to be dropped on the hammer jammer doing the solos. You can just freestyle, slapping that bass however you want it to.
Yeah.
Woo!
Woo!
Woo-hoo! Made me really happy. Like, just mute the bass channels, no marbles gets dropped, and you like
Exactly. And if you think of it, this loop machine down here is playing. Here is my ship, captain's ship. It was there all the time. So this loop machine can play forever and can play, and then you can play on the bass. How long you want. Okay, let's get to it.
Here we go. Immediately in chat. B-Boot Champ. Hannes is 1000% right. That's what we like to hear. Woohoo!
So it's lovely to have your company, and let's have a nice, fun Friday evening. It's evening for us.
Yeah.
Maybe where you are, it's some other time of day, but where we also get some things done. So there are two crossroads that we're standing in front of right now that are huge design crossroads. One is where I'm going to be standing, and right now I'm really going for this position.
Yep.
The other crossroads is what kind of memory should we have for this machine? And basing it on a loop with all its limitations is probably the creativity that I tried to make from the beginning of the marble machine, of the original marble machine. So let's try that. I have to figure one thing out. Can the loop machine play in waltz tempo? That's a mathematical thing I haven't figured out yet, but my feeling is yes. But I might be wrong about that. Let's hope not.
I'm just gonna adjust my mic here a little bit. Let's see.
So let me go.
Oh, there we go.
Are you comfortable?
Yes.
Yes. Nice.
Pulse and blood, sweat and gears, baby. That's you're completely right. Hannes is 3000% right. Jared Hansen. Yeah, I know it. I know some stuff at least.
We've been talking about the machine the whole day, and your insights are sometimes better than mine because you still have, even though you and me you've been in the middle of this marble machine hurricane for since the beginning of time, you still have some kind of other perspective than I do.
Yeah, you're struggling with building it, and I'm still kind of a fan of it. You know. Perhaps it's like that.
I think so. So I'm going to try to be very serious with this CADing. So let's do this seriously because this might be. Let me know.
Lunch packed 180. How many Swedes do you need to design a marble machine? 2. 1 to design it and 1 to go woo.
That is too true. So I'm going to. So this was another idea for snapping this in. I had the ball detent thing. It was cool because we could revolve these ball detents from the side without using the aggregate head. But then I realized that I have a better solution with the pin. So let me start to work on that. And I'm going to, as I said, try to get some serious CAD done now on a Friday evening.
And PK Margo, Hannes did not read me. I'm sorry, I can't always read everything, but let's see what you wrote. I can scroll up here. PK Margo, Martin, many music boxes can store up to 6 different tunes in a single cylinder. Have you considered this instead of, or maybe in addition to a removable drum, you could change program while playing?
So the way that is working is that the pins is programmed in a spiral. So you shift the drum over, or just it can be in a spiral. Then you can have a 5 revolution long song in a spiral, or you can just shift it over, and the pins, and you get a new song. I have thought about it, but I just think it's too difficult or not practical because basically the registrators would be so thin and the pins would be so thin. So yeah. So the idea now is just like on the Marble Machine X to have a spare set of roles that someone can program off the machine while playing song 1. Roles are programmed off the machine and then we switch them back. I think that's gonna be awesome.
Yes.
Strange timing of that one. So let's go back here.
So how is everyone in chat doing this fine Friday evening for us? Perhaps it's day or morning for you. Greetings all the way from Japan.
Oh,
Jean-Philippe Douarville Blasé. Bibu Champ, this is a crazy idea, but would it be possible to have a bicycle-style derailleur on the loop machine to be able to change the loop speed/tempo? It would shift the belt onto a larger/smaller sprocket.
They talked about some bike thing earlier. Is this the same thing?
I'm not sure.
No, me neither. Thinking if I should start. Yeah, it sounds too complicated. It's my feeling. So I'm going to delete these because they are not going to be on this thing. We don't need them. In this solution, we don't need them at all. We just need them when machining. So delete.
Chris Farmer just hitting lunchtime in Los Angeles. It's a beautiful day to work from home and listen to you two in the background. Nice, Chris. And Connor, hi from Kentucky, USA. I'm currently at work listening in the background.
Fantastic. It's so nice to have company on our work time together. And we're happy that this time, evening time for us, it's maybe a little bit better for people across the pond. That's fun. So let me see what this is. Check what this sketch is. Nothing.
So let's see. We have Joey D, who said a couple of days ago, and he will say it again, look for a ball lock Clevis pin. It will solve a lot of problems. Because I can Google that for us, see what that is for something.
Interesting. So the solution I have come up with this pin that led me to making this thumbnail is saving what I think a lot of programming surface. That will take up the least possible space on these things, which means we can make them as small as possible because they're already ginormous.
Let's see what we have here. This is a ball lock Clevis pin.
They are beautiful.
What makes these so great that will solve a lot of problems for us? Could you specify that, Joey?
I can actually show from McMaster Car the spring-loaded pins. There's a plethora. If you just look at this crazy category, this is where I found them. So
he says for the programming pins to use those.
Can you show them to me again?
Yep. So like this, I guess, right?
Oh,
here is something. Perhaps that is
but
nice.
I don't know if they exist in 3mm. I'm gonna try on. I'm gonna look on McMaster Car. Okay, but check this out. How many of these we have? Oh, this looks cool. Lockpin. I'm gonna check for it on McMaster Car. So all these are spring-loaded pins. And so I think it's kind of crazy. 3,917 products.
Just start scrolling through them. We got all night.
Another thing that someone sent that we have actually in the programming pins. Talking about programming pins, you should pull that up. There's a suggestion, Hannes, in Programming Wheel to use, instead of the O-ring idea, to just use these slotted spring pins. So,
was that an old suggestion?
No, it's in the new.
In the new?
So let's say if we have them in metric. Yeah, 4mm is the smallest one. How long is this? 4mm length. What? No, 1mm dia. Oh, and here's, oh wow, we have them in every. Here's 3. Ooh. Here's 3mm diameter. Let's try 20. So I think what you're suggesting with the ball pin is the same thing, that we can just make, we can find a pin that has a press fit designed into it from the beginning. So here's the pin. Just want to hide this body. So it's like a pin with a little groove. So when you put it into a hole, you can like push it in with some force, and then you can take it out, and it has press fit built into itself. This, I think, makes a lot of sense, and I think this is actually a better idea than the ball detent. Did you have the suggestion for the spring pin?
I have a couple. Can we just scroll them through?
Yeah.
In that folder?
Yeah.
Let's take a quick look.
Oh, take the next. I just want to show the. Take the next one. I'm gonna look at this later. Yeah, next one. Here. So Dirk says use spring pins as programming pins. No need for venting holes.
Sorry.
No need for machining a groove for rubber. Cheap because standard part. Include breaking point on errors. Maybe, maybe not. Tolerances in holes, no problems. So this is. I can't think of a simpler idea than to use a rotary CNC machine and just drill holes and insert spring pins. I think this is a winning combination, Hannes 3000.
Woohoo!
Yeah, so I don't actually want to derail this stream with too much programming pins discussions, but I think the spring pins is a very, very good, path forward, because I want to show you how I think we can replace these drums in a very safe and repeatable way. Let's delete this. Just deleting everything that I had in this design. Oh, that's the hall. Let's delete that. Let's delete this. Let's delete this. I think I could have started from scratch, but hey.
Some people have some experience of spring pins and saying they can be really hard to get out and even in.
Yeah.
Needs a punch and hammer to remove.
Okay, so that doesn't sound good. We need something very... We need something lighter than that. Okay, let's go to CAD because now I want to go for the thing I wanted to show you. So I'm going to make a middle line here as well, which is 880. So we have the middle line. First of all, when we insert the drums, we need to insert them so they always end up at the same position. And then I thought that we can make that really nice in a nice way by having underneath some resting pins, which means that we can just lay the drum in and it's resting in a secure position. So I'm going to cut with a CNC machine some resting holes, and I'm going to do it differently on the two sides, which means that you can never put a drum in the wrong placement. So this will be very important for the programming and for the music and the crank and everything, that everything is just very repeatable. So let's do some nice angle here, 30 and 30.
Okay, so we'll see what we agree on later, but people are, they have some experience with those kinds of spring pins, saying that it's really hard to, it all depends on the tolerances of the holes. It's kind of tricky to get it right so that it doesn't get too hard to remove them. That's why some of the people are, for example, the Clevis pins might be more friendly on the programming pin plastic over time also. And it's easier to take out again.
I'm going to search for Clevis pins here on McMaster Car, Clevis pins.
Because it's a ball lock, and ball lock will easily inject and easy to reject. And they will keep in place because of the ball lock.
Yeah, so I've been here, I've been looking at these, and I've not seen them small enough, I think. See, they start at 8mm. No, here's 3. Headless Clevis pins with retaining ring grooves. So no ball. This doesn't have a ball detent, I don't think. Retaining ring grooves.
It looks not right.
So this goes for...
What did you search on, Martin?
Clevis pins.
Ball lock Clevis.
Yes, so we have these, but they start from 8mm. They're too large because you need to fit a spring and a ball inside. So I wanted this first as well, but we can't use 8mm pins. That's why I still think the O-ring is a good option. But anyway, the direction to use something like this is good. One of these. If the spring pin is not flexible, then I agree. Either it will not grip, or it will be too tight. So here I'm going to cut these resting pins that I talked about. Let's do 45. So it's lying safe. And this one, I'm gonna do a parameter on the fly, which I learned yesterday from a super nice comment on the stream. I checked it up after the stream. Anywhere in Fusion, you can just create a parameter on the fly, they call it. So I say pin size equals, sorry, I lost the zoom. And I say 6.
Oh,
So there's 6, and it doesn't look like a function, but it is. Because if I go over here to the other hole, and I say I want to constrain you, I just write P, and there's the pin size.
Oh, wow.
And it becomes 6.
Nice.
So now I have a parameter on the fly. It's a little cool trick, actually.
On the fly, everybody. Woo!
And then I'm going to put in some key pins at random positions. It's not going to be random, but I mean at another position than the... So pin size again. And I'm going to put another one here. So pin size, boom. Let's constrain the angle of those as well. And then for the other side, we're going to make another configuration. Because I like the fact that you will not be able to rest the drum in the wrong position when you change them out. Right?
Right. And here we are, Scared the Fish. Hello from Saturday morning in New Zealand.
Oh, wow. That's a brain twister,
They are in front of us, Martin. We need to catch up.
That's a little hard to fathom. So, and then let's CAD the pinhole for the twist lock pin, the one on the thumbnail. So it's 6 millimeter, so let's make 6. So how many of these do we want? Let's make a circular pattern. Should not overdo it. I think 8 is plenty. $12 or 8? No, 8 is good. So that's the holes for those pins. And let me see, this ended up on the same space.
Jerome Blomshire, just use Lego spring pins and go full circle. Fredrik Idborg, glöm inte bort vätskenivån. Skål på er.
Skål, det är fredag.
Skål. Oh, I have nothing to drink.
Oh,
Well, I will sort that soon.
you have to go fix that. I'm going to make both sides. I should have some kind of system for these angles. So they're just random now. So 360 divided by 16. The hole will end up exactly in between these holes. And then I'm going to do 360 divided by 8. Now I want one more. So plus 22.5. I think that's nice. 22.5. And this looks a little more proper.
Oof.
67.5.
And Isaku here says, good evening from Trinidad and Tobago.
Oh, cool.
Wow.
Super
Sometimes
cool.
Yeah, my mind just gets blown sometimes with, oh my God, we have viewers from all over the world. And here we sit in our little streaming studio, reaching all these wonderful people.
It's awesome. Thanks for joining us. There we go. This will be my pattern. So if we now extrude through this 1 meter. Boom, here's a drum. I'm going to drill the holes for this pin. Let me find where it is. Slotted spring pins. Okay, I have to insert it again. Let me go and get the pin.
A technical question here from aka Marco69. Hey Hannes, can you check with Martin if he will have enough X travel to drill hole using angle head plus length of drill stick out? Also, the CAD model of machine shows not enough Z height.
So very, very good question. I think one, I'm just going to import this MTDS6. This is the one without thread locker. This is the one I want. Download the step file. You are a Gretzky skating where the puck is going because I think the X travel is difficult. So the C height, the question is about how this CNC machine will able to
Is it called C height?
yeah, CZ.
Is that the same thing?
Yeah. So Z probably, which is Z. So Alex CNC have made these precision plate designs, which means that we can lower the whole gantry. The whole axis can be lowered so that this thing is touching the floor. And it's on the CAD, it's in the highest position. So the Z height is going to be enough when we lower it to the lowest position. I could kind of illustrate it by making a sketch here. This really wants to be on this side. So if I make a 110 circle here, which is larger than the thing we're gonna cut, it can be down here. And as you can see, it's kind of hard to get to that. Our diameter is actually 900. So if I pull this down to here, you can see that the surface of the cut is on the CNC table. So that's 20 centimeter under. The second question though is about these aggregate heads. Let me see. I'm gonna have to go.
Whoa! Caught me off guard there.
And this, I think, it's more tricky. So then we have to look from this direction to see if we can fit in an aggregate head and still be able to reach the side of this thing. This thing is hopefully longer than what we need, but not sure. So this is a good question. I am not sure we can... I'm not showing it. So this, if you think of it, it's sitting here, needs to fit with the drill right here. I think that might be an issue. So well spotted. Eagle-eyed Gretzky in the chat. Let's go back to the programming wheel. So here we can see how far this pin is protruding from kind of the surface. I'm going to drill a hole just a little bit over that. From here to here is measured strange. From this plane to this plane, 5 millimeters. But depending on drill and stuff, I think we should go a little bit deeper. So let's go 8. And I'm just gonna take them all. I should perhaps not do that. I should perhaps just do a circular pattern on the feature. So
KK Altair just enter the live stream and Martin is looking at saws. That can't bode well.
I'm taking this cut feature and I'm rotating it around this axis 8 times. Boom. And then I'm going to do the same on the other side, which I'm going to do over a mirror plane. Mid plane, I mean.
Just want to say this here real quick from B Bootchamp. McMaster car has a half groove dowel pin pre-grooved for O-rings. It comes in 3.125 millimeter and 2.38 millimeter dia.
Can you give me the name again?
Half groove dowel pin.
Half groove dowel pin. I checked these and for some reason I didn't find full groove dowel pin. So we want a retaining ring groove. So these are close. Let's go metric. Oh, they're only in inches. Okay, we can drill inches.
It comes in 3.125 millimeters and 2.38 millimeters.
Yeah. So I don't think that groove is big enough for an O-ring, but perhaps. It would be good to exclude, to don't have to manually machine them. Or, I mean, custom machine them.
Yeah. Simple as possible.
Mirror this cut pattern over the mid plane. That will cut the same holes on the other side. Yeah. So I really like the idea of having this indexing to this big drum with these small pins into these holes, because it leaves so much room for programming tracks on top here. I think it's great. And then I want to cut our resting pin positions, and that's going to be at the surface. So I kind of think that one looks strange.
Okay, follow up here from B Bootchamp. No, not those ones. It was on the screen. Half grooved double pin with notch.
Half grooved dowel pin. Okay, let's just go for dowel pin.
Half grooved with notch.
Half grooved. Oh! Here we go. Gretzky in the chat. Oh, wow. It's even for a spring like that. That's cool. Inches. Only in inches for me, but I can probably... What is 332? Let me download this one. Where did you go? Sometimes it's here somewhere. Oh, it's there. It's very, very short.
Just had B Bootchamp screaming out yes in chat.
What is this? Why is it... What's this strange shape on the side of it? typical when you find the thing you want and they make something you don't want. Ooh, this is 2.383 millimeters. Okay, brilliant catch from you. Thank you for being persistent. I'm going to note this into here. Half grooved dowel pin. Ready for O-rings. Do you know if they are specially made for O-rings? Is that, or is it just a groove? Random groove. So
they are designed to be pressed in a hole to hold a spring in the groove.
Yeah, that was on the picture.
Okay.
33.8.
And Joey D has concerns about O-rings. He thinks O-rings will make the timing off because of tolerances.
The idea is that O-ring, the pin is straight from the precision fit of the hole. So the idea is that I hate when Fusion makes these lines. Anyway, so the idea is that it should not do that. So here is my kicker idea. So in the surface, we can machine this. I'm going to make 6 millimeter, maybe 10 cutouts like this. And that means that when all the slots are opened, we can just lay the programming wheel to rest on these pins that sits in the gear. Mm-hmm. And by cutting another configuration on the other side, we can fix that. So anytime you see these kind of lines, you should beware a little bit because it's these extrusion lines. They should not be there. I don't like when Fusion do that. Is it me?
It's not you, it's me.
It was me. It was not Fusion. It was me. Now we have a cleaner look here. What's this now? Oh, okay.
Bibu Champ. This is the first time someone has called me persistent with a positive tone in their voice. Lucas Wendel. I wouldn't worry too much about the pins. Any CNC shop with a bar-fed lathe can groove, and part of ground stock shouldn't be too expensive per pin.
That was what Alex CNC said also. A CNC lathe will spit out these things, he said. Now there's something wrong here with this cut feature. I have no clue. So I'm trying to cut. I'm just gonna read. You see, it doesn't look right here.
Oh. Someone messed up.
Yeah.
Probably Fusion, right?
I would say that's absolutely the most likely.
Yeah.
Oh, I should cut. Of course, I'm stupid. I should cut the whole circle because Fusion don't like when planes are like exactly next to each other. So I'm cutting the whole circle, and this should be end of all our troubles.
And Martin, if you would be so kind, could you just explain a little bit what you're actually doing right now?
So we are talking about how to make the big programmable drum removable from the machine. In the previous stream, we also even talked about using a paper programming, which would not need these drums at all. We were discussing wildly the whole day about that. Right now, the drums are still in. And then we made this solution for removing them. So you could open this captain ship here. I made it.
Yar.
So I had a boat steering wheel here. And on the lower one, I had a coronavirus to open. To open this, and then this green thing went to the right, and you could take it out. And it's just not space efficient. And I figured out, thanks to these amazing twist to lock pins, that we could make a very, very space efficient and material efficient solution.
To fasten the drums.
Yeah, to take the drums on and off.
Yeah, there we go, chat. Hope you are happy with that.
So let's now make the other side. Yeah. So I'm going to sketch the other side. And I'm projecting this sketch. No, wait, where? Okay, yeah. On the body, which is not really professional. I'm doing it anyway. And my idea here is the thing that I wanted to kind of talk about, is that I want another configuration on this side. So let's project these lines as well. God, I'm slow when I'm talking. Come on. I wanna learn to be fast in these streams. I think that these streams are helping the project immensely, but I want like everyone to feel like, whoa, things are happening. I don't want people to feel. I want to be fast.
Yeah, but if you're too fast, no one can follow along what you're doing. We're trying to find a middle road there. Some people actually learn stuff from you when you're working like this, Martin. Don't forget that.
That is true. Thank you, Hannes. So I'm cutting almost the same holes, but here is the new hole. I'm cutting on this side. So there's one hole off. And what did we say? 8. Which means that this drum can only rest on these pins in one direction. And 10 we did. And what I'm doing here is just so when all the lock pins are open, the drum will be able to rest by itself. So if you think this is a huge one, if you have to hold it in the perfect position and then put all the pins in, it's gonna be horror show. So these little grooves you see on the surface here is like indexing grooves, where we can rest the drum while all the pin is locked and it won't fall down, and then you can grab the drum and lift it off the machine.
A lot of people in chat is pointing me towards this comment that I think I should read, so hold on to your butt, Martin.
Yeah.
Lee Smith, suggestion. Instead of spacing the pins evenly, put one deliberately out of position. That way the drum can only possibly be fitted one way around and it becomes impossible to misalign it by one pin.
Gretzky's in the chat. That's exactly what I've been talking about. So look here. That pin is different than that pin.
Ooh.
And Gretzky's in the chat. So there's only so these indexing pins should take care of that. But you are right. We could make it even more secure, that if we see that a pin is not going in. No, basically the drum, no pins will go in if they put it in the wrong position, because one pin here will prevent everything from going in. So this is exactly my idea.
Okay.
So
Brilliant viewers.
yes, Gretzky's in the chat. Skating where the puck is going. So let's now take this, our friend. I almost called this video the best pin in the world. Some engineering clickbait, high level engineering clickbait. But instead I went with the totally non-clickbait. This pin just saved our Friday. Look at that pin. Isn't that a little exciting? There we go. And I'm going to just copy this so we feel. So we have 8 of those there. I'm going to mirror all those over to the other side just for fun. We're having fun here. It's your own world. You can put a pin wherever you want to. A happy little pin. Right?
B-Boot Champ, one thing I've asked a few times is if Martin will be open to using 3D printed parts this time. Resin prints can be such high quality and even transparent.
Yeah, I'm much more understanding of the 3D printing world now. And sure, if it's the correct material and the correct part for correct manufacturer process for the part, I'm not against it.
Do you know who's against it though? That guy up there in the corner that's watching ominously over our shoulders.
Yeah,
Keeping us in line.
of course. Never happy, is he? So there's the pins, and the magic of these pins is of course that you can retract them with your hand, turn them 90 degrees and lock them in their open position. So let me now CAD these resting pins that I'm talking about to make things maybe a little bit more. Yeah, then I can show this. That's good. So new component, resting pins. And these will not be retractable. They will just sit in the gears and the hubs. So there will be a resting pin here, one here.
Dan R. Hansen. Hi from Denmark. Will you be utilizing aluminium extrusions for the machine frame this time?
Ooh, that's a good idea. Hi, Denmark. That seems... You mean like the 80-20 stuff? Like the... it's like the frame of the CNC machine, right? Is that what you mean? That could be a very good idea. I know there are some similar stainless steel that David Lewis, the machinist, has been talking to me about as well. So same principle. It's like a... I guess you could say it's like a Lego kit. Lego kit steel frame. I'm gonna show it soon on the CNC machine so everyone knows what you're talking about. We're gonna do 2 sides on these. 16. So here's the resting pins. I'm soon gonna do the other side first. I'm just gonna point out that these are the kind of frame parts I think that's being referred to. So
Oh, okay, yeah.
yeah. And then you could put things in these slots and it's more like a big Lego kit for a frame.
Wow.
Yeah, something like that, instead of just square tubing. The other idea is to use 24/7 steel that have laser cut in square tubing. So for example, if you want a weld joint or something, you can laser cut in a square tube with them. So that could also be another idea.
Boom.
Boom. Let's now make the resting pins on the other side.
80/40 extrusion.
Yes.
James Churchill.
Did I say 80/20?
80/20. That's the motto we live by.
Yeah. The Pareto principle. -8, which means that 20% of the work that gives 80% of the outcomes or something like that. -16. So here's my point. We lift the drum off. Ooh, we lift it off. What?
It comes with a sound effect. I love that.
And as you can see, these 4 pins sit in another configuration than these 4. And this drum can only fit back here in one way. And if we didn't fit it, and then it can rest on these pins. When all these pins are in the open position, we just put the pin, we just lay the thing down there, and then we close all the pins in. And the thing is stuck to the thing. And what is kind of amazing is that we can put the first programming track already after like 1 centimeter here. So these stick in, what did I say, 5 millimeter. So I should actually have maybe even less protruding here, so we can start the first programming track even earlier. But maybe that's a little greedy. So these pins sits in the hubs, and this is maybe where so let's make the hub. And this is where my feeling... I don't know how we can make the hubs being really straight, because there's nothing actually locking. This is where this might... We need a strong hub. Not just a bearing on a little shaft. We need something better than that, perhaps. How could we do that? So, right hub. The left hub is going to be the gear.
B-Boot Champ is on fire today. Have we completely ruled out the possibility that Martin can tape all the instruments to Hannes 3000 and he just throws marbles at him to play the music? Hannes has a body now. Use it!
That was never really an option. So, boom.
Shakalaka. At Cirque on my way to work on a Saturday morning watching Martin and Hannes. Cheers from Australia.
Wow, Saturday already.
Yeah, cheers. And good luck at work. Cheers. As you can see, we're also hard at work here.
Yep. So fun to hear where people are from all over the world. I'm a big believer in our future because of globalization. In the end, we're gonna understand that we live on this pale blue dot in space. I think we can become friends, all of us. Right, Wilson?
Yeah. No, if you ask this guy, he would just say, "Not a chance in the world." But I believe it, Martin.
Good.
I've seen it in chat. People turn around. They have an idea that they're really fighting hard for, and then they get some evidence from you or another one in the chat, and they're like, "Okay, I hear you. I understand."
That's like a famous science story. There was some scientist who've been working with this theory his whole life, and then this super famous professor, some astrophysics or something word like that, and there came this new young scientist who had done some experiments and came to the university and made a lecture, and the evidence in the lecture invalidated most of the professor's life's work. And so after the lecture was over, everyone was turning around to see how will this famous professor react. And this professor just slowly started to walk to the stage, just went up, and just shook his hand and said, "Thank you for proving me wrong." And everyone's erupted in a big applause.
I mean, that's goosebumps right there.
It's the scientific method it's the close. I love it. I love it. I believe in it. Or it's not a matter of belief, according to this. So
another Gretzky here in chat, Memeplex. Hannes, have you been bench pressing so you'll be able to lift the drum? Mine is 1 meter wide and almost 1 meter high, out and in on stage. Exactly. That's why I started. I saw this coming. Martin told me 2 years ago, you need to really step up your bench pressing now. You're going to have big drums coming in.
We have a weight calculator in the public link pasting document. You can actually calculate the weight later. So circular pattern on this, and we will have our spokes.
AKA Marco69. Spokes are so easy to CAD these days.
Someone have seen me. That tells me you have seen me do this a lot of times now. So let's do this for a hub. I am a little bit worried about something. What will actually keep this hub really solid? Is my whole pin thing a lie? Have I been lying to you this whole stream? I want to project the pinholes from this sketch. Is it here, the sketch? How can we do, yeah, this is, I'm finding a weakness in my own thesis, and I'm not as happy as that lovely professor we just talked about. There's one thing when someone else comes and proves you wrong, but when you prove yourself wrong, less fun, right? Okay, sorry, let me just find this. And why are there lines all over the drum now?
Oh, man.
So here's the sketch. The sketch is there. Let me just project that and let me hide that sketch. Yes. So for these pins, it was M10. So I'm gonna drill like for now an 8mm hole just to exemplify. Yeah, so there's nothing really keeping this hub tight. Look, like pushing the hub to the side. It's just a pin, so oh my god, my wonderful solution. Maybe it's not so good, Hannes.
What am I hearing? This is not what I want to hear.
No, me neither. Me neither. What? Okay, here we go. Now I recognize myself.
You know what, Martin? I'm gonna head out and prepare some thinking juice.
Yes.
Yes.
Friday thinking juice.
Yeah. Be right back.
To make this design work. So this is why I love this design. I think this was so cool if you think of these pins, that you can open all the pins and just take this out. But we need to make this sideways stable somehow. We can of course press it towards each other. So if it's a little bit hard to get this in, that you really have to press it, they will press outwards. That will be enough, I think. But it would really require it to be a little bit of a press. But I'm not against that. So what I mean is that these are not screws. They're not screwed into the HDP from the side. So it's nothing that actually locks these together. These are so big and so heavy, so it will kind of like fall into place by itself, I was hoping. But we really need to press it on the sides. So on the other side, it's going to be the pulley. Let me insert this. So this is now a normal pulley. Here. Cancel. Let me join this thing to here. That's a little small right now. $900. Okay, yeah, I should machine it down. Let me do that later. Let me just think like, because what I'm worried about now is that because we do not have a shaft through this whole thing, because we want to be able to take this out. So I'm worried about the sideways stability of this yellow thing. That's what I'm thinking about. Oh, thank you. Friday stream. Cozy. Let me bring this hub over here as well. Boom. It's this sideways efficiency that made me love this idea so much. But what I realize now is that how can we really... If we just push it to the side really thoroughly, so the drum is press fitted into place, it has nowhere to go, and it will work.
Mr. B Fox 1775, just use bolts and bolt it to the side pieces.
Yeah, but we need to do that between all the songs. So then we would have to the cool thing is that you can just click it out. You could of course use threaded inserts. We could machine like Formula 1. Someone could just come up with a screw gun and 8 bolts, but probably not all these bolts are easy to reach. And then we can put threaded inserts in the plastic. I think as long as... Let me make the shaft. I think maybe that... Oh, we can use the flanged bearings. A large flanged bearing here. And then if it's just a press fit... Am I being stupid here? I don't think so. I'm fighting for sideways efficiency. Maybe a little bit too much.
And chat, if chat has any good solutions, the best way is if you explain it and upload it to the Dropbox. Instructions is in the description, so we can take a closer look of your solutions. If you have really great ideas. In the meantime, Martin, cheers, my friend.
Cheers.
Cheers.
Cheers, everyone.
Cheers.
Thanks for joining.
Friday night
Cheers,
stream.
Wilson. I know you don't like me, but I'm happy you're here anyway.
I don't hate you. Just don't like you.
Because the whole idea is to not have a shaft in this solution. I have to find out what these holes are doing. Why are they so long? New sketch. Here.
So what are we working on right now? Is it the wheel or pins wheel, right?
It's the way to remove... we're still at how to remove...
Yeah, well, I'm thinking about suggestions here. This is the wheel concerning the programming wheel, right?
Okay. Yeah. Programming wheel.
Yeah, nice.
So I'm thinking it's only gonna be like a very short shaft, and then we can use like a flanged press fit bearing would be like super simple. Let me go get one from a master car. Flanged bearing. I think they are super beautiful. No, I don't want these. I want... Or maybe I do want these. No, I don't think so. For shaft diameter, let's go oversized like we did. Oh, these are not the ones I mean actually. But they're pretty cool. Flange thickness. That's... Oh, these are... What? $175? No. I'm going to search for bearings instead. Ball bearings. Ah, here, flange. These are the ones I'm looking for. Metric. 20 millimeter. These are beautiful. Housing, let's go 32. Oh, only 7 millimeter. They are so smart, these. Let's see how thick the wide one is. 9 millimeter sounds a little bit better. Download. So my idea is that we can just have one of these cute little flange bearings in here. I have to adjust the size of this hole. What's the diameter here? 37. Let's go 37 on the hub. 37. I had like 100 bearings on the programming wheel on the Marble Machine X. For this mega wheel, I'm just going to trust like 2. But my point here is that we're not getting any stability from this little thing. And that it freaks me out a little bit. But maybe it doesn't have to. Let's mirror this bearing over to the other side, over our midplane. There we go. Look, we have our first bearing on our shaft. But the idea here is that nothing can actually stick out. So this shaft cannot stick out like this, because then we can't get the drum out. So it has to be in there. Can we fit a small little something? And then we take the drum off. This whole thing can fall apart. We can fit a little stop ring here. Yeah. I think this could work. But it needs some tweaking.
Chat is saying that there are a couple good suggestions in the Dropbox right now. Should we take a look at some?
I would love to.
I'm in the programming wheel.
Yeah, I'm just going to, before we go there, let me just import this into the...
That's important.
Let me import it into the main model, and just to feel that things are happening. So later this spoke is going to be the same as this. And I did the same mistake. We have to do a rigid group. You can see that everything did not follow. Nothing basically worked. So what you have to do then is that you have to make a rigid group. Woo! Let's go and make a rigid group of this whole thing. And then when we update, it should pop into place. Something go wrong. Wait, do we have... Oh, it was already imported. I'm stupid. Because I redid the previous. Okay, good, good, good. I like the simplicity of this. So yeah, let's check the suggestions. 3000.
Let's see what we have in this folder at the moment. Oh, first off, seems to be with the paper in mind.
Paper or plastic, spike wheel, paper lies on top of prog wheel. If no hole in paper, spike wheel cannot engage with prog wheel. If paper has a hole, spike enters prog wheel hole and prog wheel drives spike wheel, which drives instrument. High torque with paper, prog wheel can be any size. So this is a way to make the paper stronger. So the paper hole goes over. Well, this is very interesting idea actually. Well done.
From Isaac Robbins.
Nice, Isaac. I think the idea is to make the paper like reliable. So you get the strength from the programming wheel. Although you have the problem, you have to manufacture both here. But this I've never seen. It's a very cool idea.
It's a really small image. I don't really know what it is. Perhaps it's one of those bicycle wires.
Okay.
I don't know.
I didn't understand it. Tighten, loosen wheel to remove cap. No additional horizontal space. Easy to machine on CNC off the shelf. Easy to find parts. Nice sketch. Yeah. So the thing is that when you add the other side to the sketch, how do you get things on and off? That's when the frame falls out. That's where you need to take things to the side. So that's where when the drum goes into a cap, only way to do it is if you come in from the side. But then the frame is in the way. So yeah, I think this would cost more sideways space.
Let's see, let me reframe a little bit here.
Center frame and drive mechanism split wheels slide on from either side. Wheels would be to go. Okay, cool. There's a lot of people who wants to split. So thanks for, what is it saying? I can't read it.
Jason.
Thank you, Jason, for this cool sketch. You have a lot of friends out there who are thinking in the same paths. And I think since my problem with the Dragon Slayer plates, having 4 sections of the programming wheel, fretting to get it correctly, I'm just dreaming about a world with a CNC programming wheel in one piece. So I want it in one piece. Put the programming wheel into the white holder part, then shift the wheel slightly to the left, close the blue part to lock it in place. Gravity should take care of up and down motion, but the blue part could be locked to the white for extra security. Military cable reel for inspiration. Yeah, so this would require the wheel to have its own hubs. So one of the things that we're trying to perform with the solution I'm doing here is a hubless programming wheel during transportation, not on the machine. So the hub stays on the machine and the extra wheel is just the part. Because the lower drum, this drum, is 800 millimeter and can fit in the bigger drum during transportation. So we have 4 of this in total, so we had 2 pairs. Let's check the next one. Paper roll with loops. Well, I can't read. Stabilizing table, yes. Oh, you dropped the marbles through the holes. Cool. That is going to be tricky in different tempos, though. Oh, this is so fascinating to see things I never thought of. So thanks, Lucas. That was awesome. Programming drum. Axle supported in bearing block that can be split or released axles some other way. Belt pulley space needed more between frame to be able belt pulley. Oh, so that's the sideways sketch.
From Lucas Vandel.
Aha, nice.
Copying from music boxes.
Space needed more between frame to be able to remove drum. Axle supported in bearing block that can be split or release the axle some other way. So another I don't fully understand, but another if we want it really stable is to just pull a whole shaft out first to the right. Actually, we made a sketch about that earlier in the previous stream. This first alternative up here, that you have a whole shaft that you just pull out to the right and then you take it out. Is that what you mean, Lucas? And then what I'm going for right now is this with no shaft. Okay, let's check the next one. Inverted belt idea for removable programming drum. So the gear is separate nowadays. So if we go to CAD, the pulley for the belt is its completely own part nowadays. So that's why if we go to the programming drum here, there's no gear here. So the gear is already separate from the programming drum, and we can also cut the gear on the CNC machine. Push the whole drum in. Yes, that's what I want to do.
Oh, wow, that was small texts everywhere.
Oh, there's more papers here.
Yeah, dropping through papers.
Equals oh, it's the same ID from 2 people. I love when that happens.
This is also Lucas, I think Lucas, who sent the earlier one.
Okay. So how do we gate so only one marble gets dropped? Cool ID though. That's talk about no part is the best part. How would it be done though? Huh. Oh, so this should be in the link. Oh, can we see the whole image? Yes. If this is working, no programming wheel chance is needed. Just discs from the side. Programming wheel. Disc pushed from the side. It looks cool, but I don't quite follow it. Drum can be unlocked. Opens, closes here.
Oh, sorry.
Open. I also don't completely follow. Locking groove. Pins on wheel slide into grooves on drum. Small rotation locks it into place. Ah. Wait. It's the that we learned in the previous stream, this lock and groove idea. So I think spontaneously it's a cool sketch, Tom. I think spontaneously I don't want to have any kind of adjustability on the position of the rotation of the drum. I just want there to be one single possible way. I don't want to lock it into place and hope it's clicked correctly. I think I just want like one. There's only one way. It can only sit in one.
There can be only one.
Exactly. There can be only one. Let's check the next one.
Oh my. It's a high one. Let's just zoom in and see what they're talking about. Multi-track.
Can I see the headline?
Multi-track programming wheel.
Multiple tracks for each channel, different. Go down. So how pin springs, track selection. So okay, let's see further down. Yeah, so this is the music box idea. If we could just tilt the registrators over. Let's entertain this suggestion. Let's entertain this suggestion. So let's go to the sketchpad. Just let's head over to the sketchpad. So let's say we have the registrators here, and let's say that we have a black pen. And let's say we had the space for it. And let's say these were all connected on some kind. Wow. It created a straight line for me. On a rail that could be switched side to side. So here comes the programming pins. But there's also pins here. So let me take another. So these are the pins for the verse that's playing right now. And these are the pins for the chorus. I don't think we have the space, but this is too cool. This is classic Lucas Wendel have a million instruments that work like this. So slide this whole thing over half a step. Chorus. Slide it to the left. Verse. And you know what? Because we don't have the magnets anymore, let's check how much space theoretically we could have on our programming drum. So let's say we make it, because it's only the readers we need to switch over actually. This might work. And I've been so annoyed because I wanted to make long music, and the paper, we talked about this a lot earlier today, like the paper would allow us to make things like fermat. A little pause here. And then we could just, with the paper, change the key and stuff like that. And me and Hannes have had fiery discussions today. No, we're going to go with the programming loop. And if we look back at the sketchpad again, we're not going to use paper. This idea to shift all the registrators over 1 time or 3 times, 2 times might work. Let's probably not, but probably not. Let's go to full screen CAD and see if we can figure this out. What do you think, Hannes?
Yeah, it can be a really cool feature.
You're skeptical?
Let me see what you have in mind. I haven't seen this before.
No. This is how they do it on... Oh, we have a video with Luke. Go to Luke, the video we made with Lucas on YouTube on the main channel. Because he's shifting the drum over to choose song. And I think we have that made it to the video. The barrel organ that sounds awful. I think Lucas agrees with that. It doesn't sound awful, it sounds awesome. I think that has a nail drum, and I think Lucas is shifting it over sideways in the video. Lucas can confirm. So let's do 1 meter here. And let's say we have 50 channels. So 1000 divided on 50. Someone will tell me what that is. Fusion will tell me what that is. Is it 20? 1000 divided on 50. It's 20, everyone. I had it right. Wait, this might work. This might work. This might work. This might be a beautiful new era. Imagine to have not 64 bars, but 128. Because there's still 10 millimeters. This depends on how much space we need sideways for each track. So with a 3 millimeter pin, oh, it's gonna be busy. So I'm gonna drill the first programming hole here, 3 millimeters. Oh, look at this. There's a lot of space because our pins are so small. This is not an issue. We can do this. And even if we want 16th and things that are really close, we can just put them here. So I'm now looking at the programming hole pattern, all possible holes. So if we then go to our registrator that we worked on the other day, here, our beautiful Registrator that I love so much. The only thing we would need to do, first of all, the linkage would need to be able to accept a 1 centimeter sideways shift. Imagine like the big lever that just moves all these 50 registrators over a centimeter, shunk. And we have like a new, ooh, if there's a programming pin in the middle when that happens. Thank you for the sound effects.
Bada boom. I'm trying to find the organ you talked about.
Yeah, that's the one.
Is it this one?
Yeah.
Let's see if we can have some sound also.
And the cool thing with the barrel inside the organ here, if you come closer, Hannes, is that there is actually 7 songs. There we go. On this same barrel. And Lucas showed, you can show how we're...
So first you need to have this up, because if you would move the barrel side to side, it would break some pins. But after that you can lift this, and this like knife gets a catch in a groove.
Okay.
And after that, if you're in the groove, you know you have the right melody, and you can read what melody you have and just count the grooves in the shaft.
And I can't wrap my head around the work of placing these bridges and these nails.
There's still one person left who does this kind of work.
That's a brilliant Lucas. Yeah, there's still one person left in the world.
You'll have to pay in advance, and the waiting list is something like 10 years now.
10 years waiting list.
Brilliant. There we go. MM3.
Show the banjo, Hannes. We have to see the banjo. We filmed an instrument.
Is it directly in the... No, it's not. Here's the banjo, right? Let's see.
Banjo orchestra.
This is brilliant.
Plucked mechanically.
Yes.
Look there.
Ooh, I love it. Martin, you ruin it. Oh, short-haired Hannes.
Nice.
And this is an accordion I think I would be able to play perfectly. Hook fast.
Good joke, Martin. Good joke.
Brilliant
10
guy.
out of 10.
Brilliant guy. Stand-up comedian.
10 out of 10. Okay, so Lucas pointed out there, sideways shift when the programming pins are in means trouble.
Divide by 51, not 50. Someone said they remind Martin.
Oh yeah, you're absolutely right about that. Because we want some space on the outside. Gretzky's in the chat, skating where the puck is going.
And also someone said video evidence, move the barrel, not the registrators. Just because it's on video, it's not automatically evidence that it's true. I have seen videos of things that were not good. So I'm just logically trying to get the statement together. I understand what you mean. I think it's much easier to slide these on a shaft than to slide the whole drum. Of course, the mechanical links after these, they only need to be slid 1 centimeter. Slide the whole drum. But how do we deal with the sideways things? Maybe if there's enough flex somehow, maybe we can get around it. So my point down here is that this poor little 3mm programming pin, it doesn't need this monster of a registrator to hit it. This is 25mm wide. So if we go to the sketch of this one, where is that one?
This is too cool. When I saw what's the name of the person who made the sketch?
Alfonso Samano.
Yeah, when I searched first Alfonso, I was like, oh, that's cool. I wish it was like remotely even like possible. And right here, right now, I think it's absolutely doable.
Chat is talking about rabbit holes now.
What rabbit holes?
This is a rabbit hole you're diving into with the sliding thing.
No. No. This is the continuation of this whole morning's discussion.
Okay.
Or do they mean a rabbit hole as in... How do they mean it?
Hashtag Team Rabbit Hole. And rabbit emojis.
This is interesting AF, Hannes 3000.
Yeah. And we have a lot of suggestions to go through still. Because when we started looking at suggestions, new ones popped up on Dropbox fast.
Hold the thought. I'm thinking about the edge case that you want to slide either the wheel or I think this works. You don't understand what kind of possibilities are opening up. We don't have to have the same melody over and over again. That repeats over and over again. That's why we love it as well. But we could like go to that thing and then back to if we wanted to. Verse and chorus, just like Alfonso showed it. So the edge case, how do we solve the edge case? When we slide something sideways and there's a programming pin right to the side of it, something needs to flex. And that's something...
Cookie crumbs. Have the verse and chorus pins always triggering. Have a muting group for each.
Now you just doubled everything on the whole machine because you doubled amount of registrators, you doubled the amount of so we need twice of these and they need to be connected. And then we only have 10 millimeter to make this whole thing. Right now we have 20 millimeter. So then we need to connect 2 registrators to 1 marble gate and then choose which one goes there. If there was some like sideways slack in this, it would be bent and stuff, of course. It's an extremely interesting suggestion. I'm gonna write it down and let's look at Alfonso's and give him credit. Sheet here. 2 tracks, prog wheel, chorus / verse. Wow, I love it.
Alfonso Samano.
How to fix edge case. I don't even think that's exactly what you mean, but maybe you meant a little bit like that. Some of it is definitely it. How to fix edge case when sliding over prog pins. Yeah. We don't want half hits and stuff. Yeah, this is not... Of course, you can end... You can end the first song with a big break. So all the music will have breaks into the new... So if you have like... pause, switch. Pause, switch. Maybe like that.
Yahoo!
Now I've made 3 parts though. Let's check next suggestion. Not... What does it say? Offered...
Shortened?
Cheers. Need some thinking oil.
Thinking juice.
Not shortened flat cut. Invasion. It's on the side.
Yeah.
Can you not rotate it?
Well, can I? Let's see. There is a button for that there. Perhaps I can.
Flat. Shaft and flat cut. Remove. Is it a programming wheel? Yeah, so I'm missing the context. I'm a little slow. Paper curves, paper wraps around, registering pins, relief channels, stiff ends tuck in. So this person is a little bit into the same thing that we saw before, that the programming wheel is supporting a paper. No, it's just to drive the paper in the correct... Yes, I'm with you on this. Stiff and tucks in. Okay, now I'm with you. It's how to drive it in a good tempo. So if we look back on our previous thing, I think what we're seeing in the sketch is these holes that we also had here. So I'm with you on that idea. At the moment, the paper is out of the discussion. Let's check the next one. Vertical toggle clamp. Ooh, that is kind of sweet. Protrudes kind of a lot, so it will make the frame wide. Okay, cool. Cool idea. Pinholes. This is what we've been working on this stream. Permanently attached to the drum. Okay, so we make some kind of little rim permanently attached to the drum. Drive wheel stays in machine. Yeah, I really like this. This is very feasible. I was hoping that we could not have it at all. This is a good one, actually. Like to make a rim. Still, we have to make that rim small enough so the smaller drum can be stored in the big one. Unique crenellation pattern. That's a cool word. Can you look up what it means?
Not exactly now.
Okay. For locking in only one position and is open to allow in setting for transport. Attach spokes on other end for strength, stability, and handholds to change out. Ooh, this is creative. Spokes, I'm gonna write this. Spokes stays on drum on one end. Yeah. that's possible. That's a good suggestion. Shaft on drum, slot in center part of rim, outside rim like on a bicycle. Axle. Shaft on drum.
A little Pac-Man there.
Yeah, yeah, that's like with the fork coming down on your bicycle. So this suggestion I really like, but you sacrifice the open drums. But this is very straightforward, and you will have something very stable. And you can just pin it in place. Here's two things. We have with belt, spring-loaded locking mechanism. Hearth toothing. That's a cool word. Oh yeah, we could machine this actually on the rotary. So spring-loaded, axial force, spring-loaded locking mechanism. Where would we put that spring? Oh, this is interesting as well. Yeah, so this would work, but it steals programming surface. Because you see you have metal and a hole on the top, and we're only using like 6mm of the side. And if we go back to the hearth locking, actually, hang on a minute, this idea, that would use nothing. That would not even use 6mm like my pins. Hearth toothing. I always love when I learn a new word. Toothing. Sideways. Efficient. But how to add axial force? When I designed the captain's ship crank, that was to make the actual force. Is it gone? This one. The idea there was some kind of spring. I kind of love the idea that we can just use the CNC machine and cut like some kind of pattern on this in the side everywhere. So just slot into place to the other thing. It's very elegant. No holes, no pins, nothing. That's elegant. This is a simple problem actually. We have too many good solutions. Okay, next one. No lockable pins needed. Spring tension shaft. So, yeah, so this is the spring tension. No friction when drum removed. So this idea together with the previous hearth tooth. Move whole shaft to assemble. Feather key. This is cool. Fancy locking pin with centering locking balls to secure the drum, which will keep everything tight and rigid. Also, it's Swedish and expensive. From Oscar.
Woohoo!
Fellow Swede right there. Kip. Is Kip Swedish? That's cool.
There we go.
Also, it's Swedish and expensive. That's funny.
Oh, what's happening here? Let's see if we can zoom in a bit.
So these are all great ideas, actually. Cam tightening option. Cone shape indents along drum and gear wheel, perhaps 6 minimum. They have to transfer the rotating force from cam tightening option. How to make sure it has enough travel so it clears. Indeed, like a quick release on a bike wheel. You can unscrew those further after unlocking to make more room. Interesting. I think I understand. We're seeing the drum from the revolve perspective. So we're seeing a profile cut out of
okay.
one side of the programming drum.
I learned something. I can flip it.
Oh, so this is a very popular idea. The thing with this idea is that I'm scared that it will sound a lot because this HTTPE is used by Blue Man Group to make sounds. I've learned today. So we have ruled this out because of sound issues.
Okay.
Yeah, that's the...
Like a bike?
Yeah. I like this actually. Maybe we should just get a bigger touring, sell more tickets to the shows, bigger touring track. We can have the spokes on, we can leave the hubs on the programming wheel. Yeah, this is super, super popular idea. Same idea here. You can have instruments in the drum because you have no spokes and stuff.
We have something more.
Fastener, swappable programming. Fastener, programming wheel. Frame rigid. Okay, so the programming wheel has a hub in it permanently, if I understand correctly. The orange thing.
Oh, okay.
Or am I seeing it wrong? Yeah, so there's a lot of bike and of course they have to replace their tires. So it's a good inspiration. Okay, cool.
And we have something more behind there as well.
For changing the programming wheel, just unlock the 4 pins, take it out and insert a new one. Spring tension, programming wheel. Yeah, this is, I think this is similar to the idea I CAD'd. But the pins are sitting a little bit further down on the spokes.
Okay, so let's see. We have a couple more.
Yeah, I just want to say, can I show CAD?
You can do that.
We're talking about surfaces that we trust on this drum, and the surfaces that we trust is the outside diameter because that is going to be run perfectly true since we machine it on this. We do not trust this surface, the inside diameter. So we can trust everything that we're machining. So if we machine, let's isolate this. If we have machined this hole with an aggregate, wrong, I didn't mean to play that. With an aggregate head, we can trust that. And we can also trust these things that we also have machined on the machine. But we do not trust this surface. So I think that's good info. Okay, let's take that. Let's take all the others. Notch. Yeah, this is also good. Just slide it in the notch. How do you lock it then? Wing nut. Okay. It's so much fun seeing all your sketches. Now this is a very similar idea. So this is good for one side. This looks brilliant for one side. Apart from the fact that we don't trust the inner dimension that well, but we can make features so that we can trust it. But how do we do on the other side? This one we saw. Color fix. One side permanently affixed to side.
Oh yeah, so you slide it on, yeah.
So is there bearings in that thing? I don't understand. If it rolls on that thing. Someone said this was inspiration from a car engine the other day, something that looked like this. Easy lift out. Ah, smart. It's a trolley made for the wheel, right? Made lock wheel. Gravity holds it. What does it say?
Holds it down. Oh, sorry.
Holds it down. Okay, cool. I thought the idea was making the trolley that just comes in and takes the wheel perfectly. When on stage, swap with hubs on drums. Yeah, this is the pin from the side idea. Screws can be removed for putting drums into each other while shipping. Okay, so this is... Yeah, you know what? This is absolutely also viable. So if we put like threaded inserts into the drum and we just put the hubs on forever and ever. Yeah, this is a good... This looks so solid, doesn't it?
Yeah.
Yeah, and you can have the whole shaft and everything and you just lay it in place. Maybe the gear. Oh, yeah.
So yeah, I think we've seen everyone now.
Cool.
For now.
Great suggestions.
Ooh, I think we did it, chat. I think we did it.
Thanks for all those suggestions. So I'm gonna marinate on this.
Yeah.
And I just have to think.
I need some thinking juice. That's what I need.
Yeah. Can you get me some juice?
Yeah.
It's getting warm in here. I'm in love with this idea of switching the registrators or the programming wheel. I don't like to slide... Oh, careful. Yeah. I don't like to slide the whole wheel because it's just so huge. Where's the registrators? Do I have it over here? Yes, here it is. So the cool thing with this we can always dream, can't we? This. Let's also take this. Let's make a rectangular pattern. I think this would be kind of fantastic. So we're talking about making the programming wheel being able to hold twice as much information and being able to play twice as long patterns, which I think would be revolutionary. I have to make it a little thinner, but not a lot. Woohoo! Hey, what happened to the bolt?
Let's lubricate our minds. Ooh.
So this is the look like this, and you just shift it over 1 centimeter, and you have a new part of the song. Is it feature creep? Is it wonderful? Oh yes, it's both.
All at once.
You could do this so easily. Like I could do from my standing position. Let me see, where is my block? I have too many designs. This I could do with my left arm with a cam lever right here. So let me show you what I mean. I can put So let me try to make a sketch plane. Make a new component. So we can have a cam lever here that pushes. So if I put the pivot point here, object visibility. Let me see those juicy sketches. And a round circle looks like this, but we're not gonna make it round. We're gonna make it a cam lever. I think it's called a cam lever.
Let's call it that for now. It's
Yes.
Friday evening.
Thank you. Thank you, Hannes Paradis. Like, well, maybe not like that. So it's an ugly one, but you will get the gist of it. So if I should add a little lever to it also to make it a lever, right?
Oh, yeah.
You could very accurately shift this whole component. You can add this whole component on a rail that is built for this to shift. So now if I push this lever around this pivot point like this, you can see how this part goes in.
Yeah.
And it will push it over. And with the correct geometry, you can make it. So here, this side is the verse, and this is the chorus. And like Per yesterday said, don't bore us, take us to the chorus.
Ooh.
So this would be like, and here will be.
Wow.
Cool, huh?
Yeah. I think you're onto something here.
This would be amazing. I'm thinking about the problem with touching the pin from the sides, like Lucas said in the thing. If you just go slow, yeah, it is a little tricky. Or maybe it lifts up at the same time.
Uh-huh.
We lift the whole thing in the same motion. Can we look at the video with Lucas again? He just lifted them. He first lifted the thing, then he shifted them. So if I make a sideways sketch on this one, we lift it at the same. Can we do that? Yeah, we can. I think we can. Don't you think we can?
Of course we can.
So show any new
On
viewers.
inside the organ here, if you come closer, Hannes, is that there is actually 7 songs programmed on this same barrel. And Lucas showed, you can show how we're...
So first you need to have this up, because if you would move the barrel side to side, it would break some pins. But after that you can lift this, and this like knife gets a catch in a groove.
Okay.
And after that, if you're in the groove, you know you have the right melody, and you can read what melody you have and just count the grooves in the shaft.
We have to lift all the
And I can't
registrators.
wrap my
Easy
head
as
around
that.
The work of placing these bridges and these nails.
There's still one person left who does this kind of work.
Wait, if we lift them, we will have another edge case where they land on top of the programming pins when we're dropping them back down again. Not so smart. I lost 3,000. So if you miss it, what we're talking about is to have a verse and a chorus. And it was a suggestion from Alfonso. I hope I remember the name correctly. And there's only one issue, that when the programming pins comes, and we have registrators and we move them sideways, they will interact in a bad way with the programming pins. The safest way is to make a pause in the music. So shift. But that's a little bit boring to always have to make a pause in the music. So my idea was to lift them before shifting, but of course then when we put them down, they end up on top of something else. Huh. Lots to marinate on. 3,000. These days are crazy when we're attacking the machine on the highest level. Sometimes it feels like we're not finishing things, and we're not really, because we're still so early when we're like trying to define the big things. Maybe you missed this. This is the hammer jammer for the bass, and this is the bass position for now. So in my design requirements document, I have mentioned the biggest questions, and I'm gonna add double length prog wheel with shifted registrators. Question mark. So the biggest question have been if we're gonna go for a paper scroll or a plastic scroll or the 64 bar loop, and we have went for the 64 bar loop today. That's the decision I think I'm done with. Anyway, for now, if we can make it double length with the programming wheel, this makes the decision even more fun. Removable programming drum or not? Yes, it's going to be removable.
Boom. Yes.
Paper loop machine plus muting. Playing position for Martin. The loop machine stays. Oh, we answered all these questions. I thought they were unanswered. Answer. Prog wheel. Removable.
There's one reader, something Ethan Dagg said, don't make them lift, make them rotate backward while shifting.
Ooh, and then if you mute... Oh, that's smart. Hold that thought. Playing position for Martin, left side. Music scroll or music drum, that's already answered up here. Double length, yes. How many double lengths do you want? Yes.
Yes, please.
Okay, so here comes a suggestion from
Ethan Daggs.
Don't just rotate. Yeah, so we need to do basically this lever needs to do a chain. We're using a super nice software called Companion when we're doing these live streams. So we're using it's called Mix Effect. We're using something called a Mix Effect and then a software called Companion, and you can program command strings. And this lever needs like a big command string. So I'm gonna write the command string here. So pull lever, mutes all tracks. Which makes it doesn't really matter what the registrator does. And then swings all registrators back. That's the Ethan's suggestion. Backwards. I'm gonna make these. Pull lever mutes all tracks, swings all registrators backwards, shifts all registrators 10 centimeter, rotates the registrators forward again, unmutes all tracks. Can we make one lever do that?
Yes. Yes, please. Pretty please.
This is too cool. This is too cool. This makes up for the paper big time. Yeah. Yeah, these days when working mostly with the high-level design decisions, it's so abstract, and I'm so impressed with everyone being here with us right now that you are like following this madness, because it is easier, I think, when I'm like CADing one part and I'm finishing that part. Right now, we're just very much in the beginning trying to like get a feel of what we want the machine to do.
Yeah.
So it's kind of abstract and kind of all over the place, so that's why.
Experimental.
Yes,
also.
yes. We're in an open mindset.
Yes.
Yeah.
Now is the time for dreaming as well. Trying to find the sweet spot of dream and reality. You know?
So brilliant, this guy, right?
Andrew Cooper, one lever to rule them all.
That's exactly what it is. Cheers.
Thinking juice.
So yeah, honestly, I don't know if I can do any more abstract concepts. Let me look at this machine from the front. The sideways shifting has me all in
A fizzy.
I was exactly. It's making me giddy.
Yoo-hoo! Friday night. Friday night.
My dream Friday night. Do you know what that is? CADing among friends from all over the world with Hannes 3000 and being sent like a curveball of a design idea that can change the future of humanity. That's my favorite Friday.
Friday night hubris.
Hannes also said, so for any new viewers, let's play the Bass Jammer video.
Of course.
Hannes also said, because the marbles are going to hit these, and we can have 8 marbles gonna hit these bass jammers, and they in turn hit the bass strings over here. And Hannes said, Martin, you can play them yourself as well with your right hand. So I could press these and get the same sound as in this video from the YouTube channel.
Big Walnut Music, here we go.
Big Walnut Music.
Perhaps I should also change the camera angle then.
Let's listen to this stuff. It's great. Barely touching these hammer jammers. What did they say? 11?
Something like that.
So shout out to Big Walnut Music YouTube channel. Pretty awesome.
Pretty freaking cool, right?
Yeah. So shift back, mute all. if we mute all, it really doesn't matter what the registrators do. Hang on. I said that there was an issue if it comes down on top.
Uh-huh.
But as long as it's muted, is it really an issue? So if it comes down on top of a pin, it will like take some time for it to fall down. Yeah, it's a good idea to swing everything back and then go forward. Yeah, the command string, I'm trying to sound like a coder. I always wish I could code. I've never coded a single line of code in my life. Pull lever, mute all tracks, swing all registrators backwards, shift all registrators 10 centimeters sideways, rotates the registrators forward again, unmute all tracks. Then you want the other way of the lever, you want the same thing to happen in backwards, in return.
Reverse.
Thank you.
That's why I'm here.
Yeah, so yeah, let's call this a CADing day. So many fantastic suggestions.
Are we done already? Burning the midnight oil.
We can hang out.
We can hang out a bit.
A little bit.
Chat.
It's Friday night. So let us know if you have any questions.
Yeah, send us your questions.
Yeah. But I don't think I will. So if you're here for the CADing, I know everyone is here for Hannes 3000. I realized that when I was streaming.
So let's do this then. Welcome everybody to the Hannes Hour.
Yes.
I will take questions now. Just bring them.
Yes.
I will take over this stream now. Enough with the CADing. Let's do some actual work. Talking.
Yeah. I think we're done with the CADing.
Make the design requirements less specific. Uh-huh.
Make the design requirements less specific.
And we also have a lot of suggestions also on Dropbox to go through if we need to do that.
Yeah, so let's do that. So we're pivoting into some kind of havoc.
Yeah. Now it's design review.
Design review. Let's go.
Hoodie Kid 100. Hannes, my girlfriend wants to know if you're single. Whoa. Sadly, no. I'm not. Sadly. That's not sadly. I am not single.
Oh, burn.
Oh, no. Oh, no. There's a lot of questions to me here. Oh, no. So let's see. I will set up a little... let's go through. We already have like 8 new programming wheel suggestions.
Oh,
so let's
cool.
start with those, right?
Yeah, definitely.
I will prepare for that.
Definitely, let's go with that.
Oh, wow.
So now this is like Twitch streaming, right? This is not YouTube streaming anymore.
Uh-huh.
This is like Twitch streaming when you really just hang out, I guess. Maybe I know that Twitch have their own culture and that in a way cooler than YouTube culture sometimes.
But we're here. That makes the decision easy, right?
Yeah, it does.
Let's see here. Let's head over to Dropbox review. Okay.
Positioning pin to keep wheel in correct timing. Circular palm wedge with lever. Slotting wedge for ease of changing drum. Fixed hub and shaft on non-gear side. So a lot of these suggestions seems to suggest that we should keep a shaft into the drums. And basically I think on most... Actually, let me make a shaft in CAD behind here. Yeah. We already have the shaft. Let me just pull it out. Like most changeable music box rolls, I think look like this. They come with a shaft. Like when you see this thing, it doesn't feel hard to replace this. And we can leave this permanently attached, as someone said. Yeah, I like the idea.
You like the idea?
Yeah.
So thank you, Callum. Mm-hmm.
1, put in. 2, in the fade. In the
Fork?
fork. Oh, is it the bike fork again?
Probably. Lock, spacer, between the wheel and the fork.
Oh, so the belt is on the right side there because you don't want to remove the belt. 1, put in. That's also a nice pattern in the side of the drum. So there's no fork. Oh, okay, wait. This is the one spoke stays on idea, which is really nice. So this I truly believe in. Except for the fact that the hearth, or what it's called, pattern save us some sideways space, but it's so little. I'm gonna note in my notes, one side spokes stays on, belt pulley stays on machine. That's pretty awesome. So the complicated side with all the gearing is just staying on the marble machine, and the other side of the drum, the pulley stays on, which means that we can still store them in each other.
Great.
What about the shaft, the axle? The axle is broken here. Yeah, because I also like the thing that's to slide the axle out to the side. Okay, let's see the next one.
That was from Paddy the Fly, so thank you.
Awesome. No through axle. Actual movement of side plate. Ah, there's a plunger thing. Indexing pins may be used. And this is very similar to most of the things we've been looking at. And I love the cut through thing. It's called something fancy. Section analysis.
Section analysis, everybody.
Slide in and turn to lock. Light bulb. G10 light bulb style.
Ooh! Cool. I understand that.
Yeah, you screwed some light bulbs in.
I've done that.
Through your days.
I've done that.
Yeah. I just don't want the whole programming wheel to be so bright. Sometimes during the tour it's good if we can keep light dark on stage. And the size of this programming wheel with the light bulb fitting, it would just ruin like the cool stage show thing.
Whoop.
I realize this adds a part or two to your build, but what if you had a hub that you could pin into the programming wheel that had a key and a keyway that then slid into a slot on the hub, which you would then pin into place? I would be happy to elaborate if you need. Cheers, Chad. This looks good. But why? Okay, so the blue wheel is used for both drums. The blue wheel doesn't go with the drum. I think this looks great. I think this looks... The red thing stays on the machine.
Oh, okay. Yeah.
Oh, there's the
Keyway.
the little green thing is the keyway.
Yeah.
So basically you have a wheel and the team comes with a drum. You take the wheel out of the drum that's going off the machine. You push it in the new drum and you push it in.
Yeah.
Which, since it's removable, we can also transport them in each other.
Yeah.
Nice one. One piece wheel outside. So this is the same sketch.
Yeah, it looks the same. Yeah, Wayne Johansson, same guy.
One piece wheel outside. Oh, wait. Now I'm getting you. The one piece to the left is stuck on the machine.
That piece? Ah, yeah.
Yeah. That stays on the marble machine. Then the wheel comes in and the outside comes in. So what I really like with this is that you have, again, the just slot straight in, no sideways space needed to get in place.
Oh, what's happening here?
Oh Lord, this looks cool. Part 3 paper programming with timing. This is too brilliant. Marbles fall through. Wait. Marbles fall through holes in paper and run along channels. Poster, banner, material. Paper moves this way and gets rewound. Marbles falls. This from John, fellow John. This is so fun. This marbles programmed directly by the paper. Like, skip all mechanics. You skip everything in between. And I think someone should do something with this idea. We saw another idea like that before, if it was from Lucas.
Yeah.
Because this is like, this is so Elon Musk like, let's just remove all the parts that are not needed. Just put all the atoms in correct place.
Can you see it?
Axle fixed to the machine. Belt drive wheel fixed to machine. Cone shape for easy alignment. Hub and spokes fixed to programming wheel. So this is great. This is also the whole thing, like keep hub and spokes to one side fixed to the programming wheel, and keep it open in the other side where it's meeting the gear. This is what I'm learning now. One side closed, one side open makes a lot of sense.
We have 3 new just while we will talk in here.
Nice.
Oh, there we go.
Beautiful colors.
Come on.
With the pins diagonally, the fixing would be more efficient and would naturally lock the barrel. Wow. That's tricky to machine though. To drill that angle.
Tricky but not impossible.
Because I don't have I did see though on this, if you look on the 4th picture from the left top, that you can like set an angle.
Whoa. That's advanced machinery.
Yep. So we would need something like that to drill those angled holes. You can actually see on the lowest row, the 4th picture has also different set angles. Split bearing carrier, stub axle on hub, bearing. Bearing carrier latches, hinge on one side, locks on other. I'm probably a little Friday slow now. Split. So this is, I'm not really following the context. It looks smart. Stub axle on hub. Bearing carrier latches, hinge on one side, locks on. Yeah, I didn't follow where we are on the machine. Is it a programming wheel hub?
It should be in this. It's in this folder at least.
Okay, yeah.
Oh, what happened here?
DJ Soldab. Hubless,
Okay. Hubless motorcycle.
mega bike. With a Wintergatan W on the white stripe.
There we go.
There we go.
So that's everything for the programming wheel.
Nice.
We have a lot of more folders though.
Yeah, let's go through them.
Yep.
So everyone, we're doing a little late Friday hanging out here together with you. We already CAD'd everything. So this is the end of the week. We're going to go through a lot of viewer suggestions.
I just wanted to see here, Shield J just said in chat here, have you looked into crowned pulleys for the flywheel? They are self-tracking / centering. A flat belt is quieter and has less friction loss than a V-belt. Steve Mold has a video talking about them.
Yeah, so we can I show Hannes?
Of course you can.
For the flywheel, we are going with a flat belt. And on the Marble Machine X, I'm going to try to open the CAD for the Marble Machine X. We had a crowned pulley. And it didn't track well because I think it was too thin or something. So on this machine, we had a crowned pulley in the tensioner here. Let me see if I can isolate it. It's not crowned here on this CAD. But we had huge tracking issues with this belt tensioner because the belt climbed up on these edges all the time. And so I know the tracking issues with a flat belt. And I've also heard that a crown pulley is self-centering. But I think, I don't know what we did wrong. Maybe it has to be, the belt has to be in good tension all the time. Perhaps. So if we go to the sketch pad, I can just show what I mean. So here's the pulley. If we look at it from the side profile, this is what's meant with a crown pulley. That you have a little heel here.
Oh, okay.
And when the belt sits on top here, it automatically is pulled into the middle. So if you see old factory images where there's long leather straps in the ceilings, there's never flanges on the pulleys. They're always crowned, like steampunk pulleys. Very seldom any flanges because they're crowned, so the belt is just sucked into the middle. I don't know why we failed on the Marble Machine X because we had a crown pulley and it still didn't track. So maybe I should watch the Steve Mold video on it. So thanks for the tip.
Steve Mold. Okay, let's dive into another folder here that is registrators.
I think I met Steve Mold in Alabama actually, but I at the time I didn't know who he was. I might be wrong with that.
Registrators, let's go.
Okay, so we're gonna go through everything we haven't seen.
Yes.
Cool. Bend the registrators. Registrator moves. Wait, bend the registrators. That sound familiar?
Yeah, we saw something about that earlier.
No, I mean if we're gonna have the sideways shift.
The plot thickens.
The plot thickens. Oh, is it for the shift? Wait, can we zoom in?
Yeah, I see the word shift enhance.
No, stiff. It's stiff.
Stiff. Oh shit. I missed it.
Registrator moves sideways. Oh, this is for the moving. This is a new suggestion. Registrator bends. Pin mode post registrators. Registrator springs back. Wait.
Gretzky?
What if it's just pivots? What if just no? I was thinking if the thing could just like pivot when we shift and then fall back into the line. This is interesting though. Chorus verse selector. Oh, everyone is on this now. So much fun. Same one chorus registrator. Chorus muted. Muted chorus verse. States. Verse by Guillermo Leone. In back dual position spring. Wait. Oh, so this is wait, I think it might be genius, but I don't understand it yet. Is it two registrators? Same registrator. One chorus, two verse. Front selector. States. In back. Guillermo Leone, I would love to understand here. So my first question, side selector level 2 spring position, dual position spring. Is it two registrators per channel or is it only one? Maybe I don't understand it. I don't know understand how it works. I would love to. Can you send another sketch? About the idea of Alfonso, can you have a mechanism that raises the... Can you zoom in?
Oh, let's see.
That raises the registrator bar above the pins while moving the registrator bar sideways to avoid breaking the pins. This could be done via the movement of the lever that switches lever between the music parts.
Verse and chorus.
From Killian. The registrator bar. Oh yeah, that's like a camshaft that lifts, that raises the... Yeah, okay, so this is the double that we change and that we at the same time... So in the third image there, the bar is on the high. And if it goes straight down and lands on top of a pin, it will temporarily not be able to fall down, but it will fall down as soon as it gets empty. So maybe the thing landing, because everything is muted anyway, landing on a pin might not be an issue. Right, Hannes?
Of course. Of course.
So thank you, Killian, for the sketch. Registrator X-axis rigid. Registrator Y-axis flexible. Ooh. Yes. So this is that it can pivot over if being hit sideways. The only problem is that they're close to each other. So when one pivot, no, then maybe they wouldn't have to. This is smart.
Brill.
Brill, a little bit hard to manufacture, but really smart. Do you understand the idea, Hannes?
Yes.
Yeah.
Let's see
Like if you have a ruler, you can bend it when you have it flat, but if you try to bend it the other way around, you can't bend it a lot. Alternative Registrator failsafe solution. Instead of having the weekend breakaway lower section for failure protection, have an insertable wooden dowel pictured or other breakable insert of some sort that can be slotted into the Registrator, possibly held in by detent or friction fit. Benefits: part that breaks is not machined, cheaply commodity material, can be placed without disassembling Registrator through. We have to make sure that it doesn't climb out. Pull forward into activated position, fine tune. Broken pieces loose in machine, doesn't stay in place. Oh, that's a risk. Best way to secure into place. Gretzky, skate where the puck is going.
Whoop, 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 whoop.
Good idea. We saw one other suggestion like that, to insert a shear thing so that it's even a smaller. You know what? Go back to the previous one. I'm going to note it. Shear pin slotted into Registrator POM for easy exchange. For example, thin wooden dowel. Thank you for the suggestion. Fishing line. Oh, is this the same thing? Easy break when stuck. Top axable to replace all push-pull force from Registrator pin side. Free to move forward and stuck. 2 muting lever receives force only from crisp. Where in the machine are we now?
It says fishing line failsafe break. It's in the Registrator folder.
Ah, it's another shear pin. Top accessible to replace line. That's pretty cool. I'm just gonna note it as well. Fishing line shear break. Now I see exactly your idea. It's pretty cool. Registrators are pushed up rather than pulled or pushed from side to side so that the wheel direction can be reversed. Yeah, so... Okay, yeah, I see what you mean. So the issue is that I don't want to reverse the wheel. Right now the wheel is... Okay, yeah, I see what you mean. Right now the wheel is going to be clockwise currently. So then the push is easier than lift up, because I don't think we can use the up movement to trigger the marble drop easily. Wine spring washer.
Non-destructive failsafe.
I'm seeing a Pac-Man game in the background.
Yeah,
of this image.
exactly. My first I saw as well. Pac-Man. Waka 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 waka.
I have some Pac-Man points for you here if you want to try
waka 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 waka
eat
waka
that.
waka.
Non-destructive failsafe. Wine spring washer. The gate. By Oxfeld. Searing ball and grooves. It looks a little complicated. It looks like many parts. Registrator arms. Bearing bill. Springway washer. Washer nuts. Registrator. From side. Oh, is this... So it can pivot. Rotate under heavy load. Okay, so cool. This is also for it to deflect when we switch from verse to chorus if it gets caught in the middle. Cool. Oh yeah, these are cool. These are the twisty.
Twisteroonies.
Twisteroonies.
From Brian Gibbons. You like them, don't you?
We could have two. If we just had two bolts, we don't have to have the L shape. I just realized. You can just have two bolts sticking out.
In the middle of the night.
21. Remove bolts. So these are the registrators. Interesting. 21. Okay, but the bolts are not really in the way. I don't think. Oh, so this is the same idea with the replaceable shear.
Yeah.
Like the wooden dowel. I always like, when I see exact same thought from two different people independent of each other, I'm like, two people had the same thought.
Perhaps two Gretzkys are at it.
Yeah.
Simpler registrator.
So you will turn these rings.
Okay.
Like you do on a mic to get a mic on a mic stand.
Yeah.
It's a pretty cool idea. It's a little sideways. It's an issue sideways, but it's a really cool idea. Cage locking nut. Oh, so that's the rack nut. Yes, I need thinner metal for that to work. But it's a cool idea. This one I don't really understand. Also, this is to make things not catch. Yeah, that's good. Oh, there was a GIF with this one, wasn't it?
Yeah, I think so, right?
Oh yeah, it's playing
No.
very slowly.
No, it's just still images.
Ah,
I don't know why it did this, but...
it opened it as a lot of still images.
Yeah. I will just scroll down here. You see the animation?
So what was this called?
Tighten it. Don't need nuts, washer, or E-clips. Diff screw.
Differential screw. So
Whoa.
diff screw. Also, it's just different. So on the front is like M4, on the back is M6, and the M6 travels further. Oh, that's pretty cool. That's really cool. Front adjustment. Okay, that's the same idea with the twist. Also, several people had that idea. That's cool. Yeah. Yeah, so that bend, I don't think 24/7 Steel will make that bend if I order that from them. I don't think their bending machine can make a radius that tight. But cool design, very efficient. Wait, I just thought of something. What if... Wait, go back one.
Go up. Stupid program.
Go back one, Skip.
There we go.
Yeah, go to this one. And can we put it in the corner? I just want to sketch something here.
Zhup.
So, what if that's actually the right idea? But we're not asking them to make the bend. We make the bend after we insert the bolt. So we order the steel profile like this. So the steel profile comes like this. Then we put in the bolt. And then we bend the part.
But what is so much better with the bent part?
Because it holds the bolt. But it will rattle and stuff. And we already solved it with the, with the lock nut. Okay, next thing. We can go full screen, yeah. Registrator by Makiex from Finland. You would also get advantage of using the bending properties of steel to reduce moving parts. Lock washer. This may need some more friction to stay in the adjusted value. Registrator.
We have one more, I think, down here.
Oh, it's from same person. Pivot point, lock washer. Registrator. Pivot point. I don't follow exactly how. I don't follow it exactly. But greetings to our beloved neighbors in the east.
Kitos. Is that something?
Yeah, this is someone pointing out that if you have a curve, the screw will become angled, and we don't have the curve anymore. So this red line problem has been averted.
So let's see. I think there was 2 new ones while we were talking. Here was something.
Ooh,
a little video.
Wow, some Gretzky in the chat. Wait, this is genius. Oh, this is why I love doing these live streams so much.
Registration cam from Thomas.
No, this is too good. So it's like, do you understand how it works, Hannes?
Yeah. Bending backwards.
Yeah, because of that little, so you get that motion automatically because you slide. It would cost probably the motion would be too steep. It looks nice in computer. It's a brilliant idea.
Wow.
No, keep on playing it. I want to.
Can't I just repeat it somewhere?
I have the value for how much it has to. I have the value for how much it has to move. Let's go to the registrator. I love that there's already ideas for the things we've been talking about in the stream. Like 1 hour later comes like a visual. Which program is this made in, you think? Do you know, Hannes?
Paint? Movie Maker?
I'm gonna delete this thing. We did check. Was it 10 degrees? Let's just find out. So I'm gonna rotate this thing backwards on this axis until it passes this programming wheel line. 9.2 degrees.
And I will keep hitting space bar here so you can watch this.
So let's just say okay.
Blender 100% from chat.
Okay, thank you, chat. Yeah, so this is. So I'm gonna show you why this is not possible. We need to move the head 15 millimeter, but of course up there we wouldn't need to move. Okay, so let me actually calculate this a little bit more seriously. The head needs to be moved. But how much does this front edge needs to be moved? So I'm going to take this part and the front edge. I'm going to copy them. I'm gonna paste them and I'm gonna rotate them around this pivot until it clears down here. So what I'm looking at is this little friend here clearing that line.
You got a fusion question here, Martin, from Upfell Musking. How do you display the measurements in the view like you did?
I'm so happy that you asked this question. This is the most useful, simplest trick ever. So I'm honored to be able to answer it. I'm gonna go over to some simpler design to demonstrate for you. What was the name?
Upfell Musking.
Yeah. So what you do is that let me just check that we have some dimensions. Now we have this one is 8 centimeters wide, and I go out of the sketch and the dimension is gone, right? And this is annoying because if we want to change it, we have to go into the sketch. So what you do is that you go over to your sketch, you right click, and you go down and choose show dimension. Oh my God, I'm so bad at making tutorials. Where is the dimension? Oh, I didn't click it. Okay. Now I clicked it properly. And now you can see all the dimensions. And the beautiful thing is that now you can also change them without clicking into the sketch mode. I can click here and I can add this to 100. And you can see the wheel is changing with in this view. So it's very easy. Right click the sketch and show dimension. Now I can hide dimension, it disappears. That's how.
Boom.
So I'm calculating the...
Yes. Chat helped me get a loop. Thank you. Joachim Monsen.
Oh, you fixed the loop?
Yeah, Joachim fixed it for me.
How?
He told me in the QuickTime short command.
Fantastic.
I work with this full time making videos and stuff, and I have no clue. I'm so bad at this. Why is that?
Because you're so goddamn good at everything else.
Oh, well, thank you, sir.
And there has to be some kind of...
some flaws.
Some kind of justice in the world. So I've been measuring how much we have to deflect to really clear the pins. And this blue line is the angle. So down here, we have to deflect 13 centimeters. But up here, it will be really heavy though. So I'm suggesting this point, and this is 6.76 centimeters. So now I can draw from the top the accurate curve.
Upfell Musking says, boom. Thank you so much.
Ah, so fun to be able to help. It's a wonderful thing. So you see this zigzag rail they have in the in the rolling thing. The problem is that we're only moving 1 centimeter sideways. So let me do like this. This is 1 centimeter sideways. And we realized that we needed at least 6.7 millimeter movement, which means 6.7. So the curve is almost a straight wall. So what I'm meaning here is that the things that are hanging down, the steel profiles, would need to slide over 45-degree angle. Less than 45-degree angle. So this would need to move. I'm just gonna do this.
And KK Altair, all I know about Fusion 360, I know from Martin.
Oh, that's fun.
Ba-ba-ba-boom!
That's fun. So when you move, when this is slid sideways, this has to go on this steep thing, and it will be too much friction. It has to travel like this.
Huh.
Or to be accurate, it has to travel from here to here.
Huh.
And doing that with 50 channels at the same time is not feasible. So awesome demonstration, but in reality, it will be too much friction.
So let's see. We have some couple more here that we saw.
But we could have a thing just coming down. Wait. Let me just CAD this.
You're not done yet, are you?
No. Look. We just make a big pin here from the side that goes across all channels, a long rail, and we just push it in like this while switching. Push and switch. Push and switch. Push and switch. Just like at the gym, Hannes. Push and switch.
Thank you for explaining that to me.
Okay, next idea.
Registrator. Okay. Mute. Lever plate.
Is this also the paint drawing courtesy of Vic? I love this crowd.
On point.
Rotating action. Wait. This is beautiful. Just follow the track. The lever follows the track. So the rotating. What happens with my mic?
I don't know.
I'm thinking how it would. Oh, because then we get the. Oh, this is cool. This is cool. So, if you put it up in the corner, Hannes.
Well, sure I can.
This thing that I just drew here would work exactly with this sketch. I think I would put. Maybe I'm looking at it from the other side. I will put the track upside down. So I would write a U. Okay, let's see it big again. I would put like a U instead of like an abstract A.
Okay.
On the other hand, you would need to use your arm to push the all channels over only from holding that thing.
Yeah.
I think that would be perhaps a little bit too much force. Super cool idea though.
Let's see what's happening here.
Yeah, let's see the bigger. Destructive, registrator, failsafe. Bearing ball between metal pieces. Spring wave washer pushes metal pieces together. If heavy load is applied, the spring washer gets compressed and metal pieces can rotate independently. Can also be positioned next to the PM bushing. Very few and standard parts. Bearing ball between metal pieces. Spring wave washer pushes metal pieces together. Spring washer gets compressed. Also, the whole thing has a. The whole thing is just going to. Okay, so this is interesting. This is another shear idea. And it's like a non-destructive shear. Tracks. One chorus, one verse. Yeah, let's see. Chorus, verse, muted selector. Oh, is this from the person that wrote before that I asked to?
Guilherme Leone.
0.2, version 0.2. Verse, track. I think the shear idea in the previous sketch is really good, by the way. 2 tracks, one chorus, one registrator. Lever can be only up, down, by the dual spring position.
What?
I'm almost... Chorus selected. Mute selected. Verse selected. Lever can be only up or down. Spring in top bottom. So I don't understand if the registrator is the lever. So maybe, yeah, I don't understand how it works. I don't understand if we talk about, I don't understand how the lever would make the registrator move this way. This is what I don't understand.
Well,
But if it would work, it would be awesome, but I don't understand how it works.
that's it for the registrators.
Yeah, let's end there,
Yep.
my friend. It's been a crazy day, high level day.
Really fun to also do this little late. A late stream.
Woo.
Burning the midnight oil here in Sweden.
And all these suggestions are absolutely wonderful. So is it now you're gonna sing Hurt with Johnny Cash, or do we have to rehearse it before?
That's not for today, my friend. That's another day.
Okay.
I'm in too good of a spirit for that song, you know?
Yeah, true. You can't really express the words right now.
No.
Not on Friday, Monday morning.
Monday morning, that's hurt time.
So we're truly honored to have so many Gretzkys here sending these wonderful suggestions.
Yeah.
My brain is exploding and imploding at the same time, which will lead to some great results in the end. So thanks, Hannes 3000, for another fantastic week.
Thank you, Martin.
Not the same without you.
And thank you, the audience, and you in the chat for being so bloody awesome.
Yep.
Keeping us company and giving all those brilliant ideas. You know what? See you next time. Take care, everyone.